So we're going to talk about cloud-native computing. What's cloud-native computing? It's all of these words. Let's highlight some of the ones that are most interesting. So cloud-native computing is an approach to computing that prioritizes things like containerization, immutable infrastructure, declarative APIs, loose coupling, and this allows you to have principles like observability, automation, and really good predictability. These are the characteristics that are embedded in modern infrastructure and are particularly exemplified by Kubernetes. Who here has heard of Kubernetes? Okay, good. Thanks for being awake for at least part of the last couple days. All right, so modern infrastructure has been about the evolution from treating servers like pets to treating them like cattle. And that's the benefit of using a cloud infrastructure like Google Compute Engine. But cattle are still solid, substantial, long-lived things. You can say, look at that cow over there, that one by the fence. You know, that one with the sarcastic look in her eyes. But with the next wave of computing, things like infrastructure, you can't really grab a hold of servers like cattle are. The nodes, the containers, the addresses, the pods, they all blink in and out of existence. And they're really only comprehensible as a collective. It's less like cattle, and it's more like a big frothing mass of microorganisms. But you know what you get from a big frothy mass of microorganisms? Beer! So modern infrastructure is great, but it's very different from the traditional ways of doing computing. So now let's take a look at how we've been doing CI/CD. Here are some of the models that describe a typical CI/CD systems. So first we have the Rube Goldberg machine. You push a button here, and that schedules a job there, and that opens a socket over there, and that sends an XML message over to that thing, which writes generated code onto a floppy, and you give it to the intern, and she runs it across the street and puts it in the mainframe, and catapults it up onto prod. And you know what? It works. But these things are kind of like a Heisenberg property. If you peel back and try and look at it, oh no, never mind, walking away. So it's very fragile. Here's, of course, the Frankenstein model. It's been cobbled together, and it's one of a kind. Beautiful, really, in its way. And this guy, he's going to lurch and lumber, slow perhaps, but steady, to get your stuff from source to prod. And every once in a while, one of his arms will fall off. But if you know where to find Dr. Frankenstein, you can call him up, and he'll stitch that arm back on. And of course, the model of the hairball. So we use these terms to describe our CI/CD systems, and we use them affectionately, because we crafted them and we know all their quirks. But let's face it, these systems are pets. In fact, this is exactly what my cat looks like. When I talk to customers about the setups they're doing, I often hear things like, we have one big server and only Susan is allowed to touch it. Or we upgraded our system and now we can run 2 simultaneous tests. Or we have one staging environment and the DBAs are always messing it up. This approach, it has worked, sorta, for a long time. But now that we move to a new kind of infrastructure, we need to change how we do CI/CD. We need cloud-native CI/CD. So right now, we as an industry are at the beginning of a major effort to establish a new kind of CI/CD. This is an effort to modernize software delivery to take advantage of all the benefits of cloud computing so that we can get things like speed, scalability, portability, and improved quality. Last month, the Linux Foundation announced the Continuous Delivery Foundation, or CDF. This is a sister project to the Cloud Native Computing Foundation. The goal of the CDF is to evangelize CI/CD, define best practices, and support collaboration between practitioners and vendors. These are the premier members of the CDF, and they include, as you can see, big tech companies, CI/CD veterans, and some customers who are active and proactive in CI/CD, like Netflix. There's also a lot of vendors that are part of the general member space, and a lot of well-known CI/CD tools are in that space. So a lot of the industry is coming together here to define a next generation. So the CDF's approach is heavily informed by Kubernetes. Kubernetes has unlocked a new level of runtime security and portability and scalability. So with the CDF, we're bringing those things to CI/CD. And we're embedding best practices so that we get containerization, immutable infrastructure, declarative APIs, all that good modern stuff. The initial projects in the CDF are Jenkins, Jenkins X, Spinnaker, and Tekton. CDF fosters communication between these projects so that we get interoperability and we establish shared best practices. Let's take a closer look at Jenkins X. Jenkins X bundles together several best-of-breed open source technologies. Things like Jenkins, Helm, Skaffold, Prow. These are all really cool open source projects that do specific things. Jenkins X puts them together into a pre-wired, batteries-included solution based on modern best practices. And it provides an on-ramp to cloud-native CI/CD while maintaining a lot of that user experience you're familiar with from Jenkins. So let's see it in action. Carlos?
OK. So I have here running an application. You can see I have, this is a very interesting game, which is shooting lasers to crocodiles, right? I could be playing this forever. It's a lot of fun. And I have it running here in the staging environment. And I have the same application, let's refresh it, in production. And you can see here at the bottom the version and the region and the commit that is being used to build this application. So this is 134 in production. I have 134 also in staging. So let's say, what is my typical development workflow? I have my project in GitHub, and I want to implement a change, right? Seems that shooting lasers to crocodiles is not very environmentally friendly. So instead, we're going to make a change to make this more politically correct. So I could do this from my machine. I'm going to just edit the file here and edit this file. I'm going to make a small change, game 2. And I'm going to say no lasers. And no, I want to create a pull request. And this would go through my typical process of code review that we're going to skip today, because I know this is going to work for sure. So what's going to happen is, if you see here, I have a bot that has commented on my pull request. It's basically telling me this pull request is not approved. This is a bot that is included in Jenkins X. And I can talk to this bot, and I can say things, very important things like meow. And my bot is gonna answer back to me, right? So I can talk to this bot. There are several commands. This is using Prow. This is a project from Kubernetes itself that they use for CI/CD of Kubernetes. So this is basically listening to webhook events and doing things. You can write your own plugins. And if you can see here, there is a serverless Jenkins, and I'm going to talk a little bit about that soon, and type checks that are still running. So if I go to my command line, and I think this is, I wanna check the logs. Wait, no. Okay. So I can see the logs of the build of this pull request happening in Kubernetes. So this is using serverless Jenkins, which is a project that we created that allows you to have serverless builds. So every time there's a webhook event coming into Jenkins X, it will create a new pod for Jenkins. So it's a small Jenkins server running that it only takes a few seconds to start. So it's not the whole thing. You don't need the UI. You don't need all extra things. And what is going to happen is going to create a pod, run that, and at the end of the build, it's going to disappear. So you have two options on Jenkins X. You have the option to have a static master, like the typical Jenkins that you know, and you have the serverless option. And this is going to be using, pretty soon, we're already integrating Tekton. If you heard about Tekton, the project, it was talked about in other sessions. So it's coming from Knative build, and it's basically allowing you to use containers in your build pipeline. So let me get back to here. This is still pending. We can take a look at why. Okay, get pods. Okay, this is still initting for some reason. We can check the logs. Okay, the pod is still, of course. Maybe my cluster is auto-scaling. Okay, wait, no. Not that one, that one. What may be happening is that this has triggered my cluster to auto-scale. So, oh, init error. Okay, so my build did fail. I can see this in the logs here. And it's not a valid, connection timeout. Oh, that's not great. So something happened here. So my build, you can see that it's a real demo because it has failed. So I think I can rerun this, and I can tell to run it again. There was some connection issue. But in the meantime, I can continue talking. Okay, this is running again. You can see here the logs from your Jenkins pipeline. So this would be the same thing that you see in a traditional Jenkins in your console output. So if we go to the previous one, it's what it's doing is, this is a Golang application, so it's building the Golang application. It uses a Skaffold to create the Docker image. You can see here the logs for the Docker image build, and then it's pushing the Docker image to a private repository before deploying it to Kubernetes. And it's also creating the Helm chart and deploying the Helm chart, because everything in Jenkins X runs as Helm charts, and it helps you specifically if you have Kubernetes applications. It helps you have a really standardized stack and pipeline for Helm charts and Kubernetes apps. So this is running make now. While this is running, I'll show you what's running behind the scenes. So this is running in a cluster in GKE. I have 2 clusters running. Okay, this is 2 machines right now. I have it in an auto-scale, so it's here somewhere. Not that one. Auto-scaling is on. So what happens is, with the combination of these serverless Jenkins and auto-scaling on GKE, the more jobs I have, the more builds I have, the cluster is going to expand, but it's also going to contract when there's no jobs running. So I get this elasticity and kind of pay as per use that you would want to a scalable CI CD. Okay, so this is still running. Before I kind of skip the questions that I always ask. Raise your hand if you're using Jenkins, please. Yes, so a lot of people. Who's using Kubernetes? A lot of people. Who's using Jenkins on Kubernetes? Just some people, okay. So this is a step forward. The other way you can run traditional Jenkins with Kubernetes, creating agents on pods. That's the plugin I started a few years ago. And this is going the next step, which is basically Jenkins serverless, you don't even need to run the Jenkins master all the time. So if this works for you, and this is not working, I think this is failing in the same step. Okay. This is, okay, so let's switch to another cluster I have and see if that works there. There's some connection going on. So I'm going to do the same thing. I'm going to edit this. I'm going to create a pull request. No lasers. So this is another project that I have in a different cluster because demos. And this should trigger the same thing if this doesn't work here. Oh, no, it fails also. Okay. So the chart repository cannot be reached. Oh, Jenkins X.io is down. Wow. I didn't expect that. Ooh. Okay. Well, that's going to be hard to fix now. All right. So let me talk through this, and hopefully things will fix themselves. And so the other thing, because I'm running this on GKE, I can get all the logs from my GKE containers on my Stackdriver. So I can filter for them, and I can see the same things I can see in the console, or I could see in the Jenkins output. You can see them in a Stackdriver. So you can see that the same error is here. So this is very cool, because then you have this permanent storage, and you can use a Stackdriver to just query it, use the APIs, build applications on top of that, and do any sort of integration you want. And we have created also at CloudBees a UI, so you can go and see what's running on staging and production environments in Jenkins X. Jenkins X by default creates namespaces for different environments. So you get the staging, you get production, and the interesting thing is that you get one pull request environment for each pull request. So if I go to a previous pull requests here, let's go to one that is closed here. Oops, no, not there. There. So when my build succeeds, what it's telling me is basically your pull request is available in this preview environment. So this is a namespace on Kubernetes, and it doesn't interfere with my staging on production environments. So I could click here. The link doesn't work now because this was deleted before, but this would send me to my application, my Helm chart deployed into a preview environment, a separate Kubernetes namespace, so I can see my pull request in action, and before merging it into master. And okay, this is running, and this is not going to work today. Right, let's trigger it again and see. Okay, if test this. Okay. Yeah, so I get, if the test fails, I get the details also. My bot is, it's all ChatOps, where your bot is talking to you, and you can do these commands. So I was talking about environments, staging and production. So if I run JX get, let me just cube off here. And if I do JX get environments, I see that I have staging, I have production, and I have two assigned GitHub repositories for each of them. So if I go to staging, what I can see here is my environment that has a YAML file where it's basically saying what applications do I have deployed into this environment. So this is GitOps. It's my environments match what is stored in Git. And whenever I want to make a change to my environments, I change it in Git, and that triggers the change in the cluster. So if my cluster disappears and I lose all the data of what applications I have deployed or anything, I could always come here and say, you know, this is the source of truth for my cluster, and I can reinstall everything based on this file. So I don't have to, you don't touch your cluster. Everything is going through Git, and Git triggers the build and the pipeline, and that ends in the cluster state with the applications that you want. So if for the staging repository, what Jenkins X does is that automatically upgrades your application to the latest in master. So when I merge my pull request, it's going to trigger a build and create a new Helm chart version. And Jenkins X is going to come here and say, in the staging environment, update the version. So all these pull requests are auto-generated by Jenkins X. So it will say promote Croc Hunter to version 134. And this will go automatically through the build. And this is a very simple pull request that Jenkins X does, which is saying, change the version 133 to 134. So this is done automatically. Staging is always matching what you have in your master branch. The other thing I have the same equivalent thing for a production environment. So if I run, let me see, if I promote an application, it's going to come here, and because it's production, I have to manually promote it using a command. And it will come here, make an update to the Git repository, and trigger the pipeline. So if this doesn't work, I'm going to skip through this and show you the promotion. So this is still failing because this site is down. So let's do something else. So I can get the applications I have running in my cluster, JX get applications. So I have 00134 in both staging and production. What I'm going to do is I'm going to promote an older version that is already built. This is probably going to be here. I'm going to promote 133, and let's see what's in there. So I can do JX promote, Croc Hunter Jenkins X, -- version 00133, -- environment production. And what this is going to do is going to create that pull request where it goes to production and says, you know, instead of 134, put 133. And while this is running, let me show you something else. I'm going to leave this running here to not miss the logs. OK, so this is doing, OK, it created a pull request. So this is a pull request against my production environment. As you can see, this is done automatically after I did the JX promote. The file change is instead of 134, go to deploy 133 in production. And this is running the build. The build has succeeded. It was merged. And now it's going to be deployed to production environment. So I can see the logs of the build and all that. Now, until recently, what this happened, what this was doing was just updating the application. So you immediately get the version you promote into production environment. One thing I've been working on is to do progressive delivery, canary deployment. So progressive delivery encompasses like canary deployments, blue-green deployments, things like that. So basically, you don't want to deploy new versions to everybody of all your users because you don't know if it's going to break something. You want to deploy it to a subset of users. So this is the typical stuff that Netflix, Facebook, Google does. So what we are doing and what I have enabled in this project is exactly that canary deployments. So I have, basically Jenkins X has the concept of applications, Jenkins X applications or extension points, and one of them is Flagger. So Flagger is a project that will do these canary deployments for you. And this is using Istio and Prometheus metrics. So what we're going to see here is that Flagger detects there's a change to my deployment in Kubernetes. And instead of switching the whole traffic to it, it's going to create the Istio deployment configuration necessary to shift traffic a little at a time. So what's going to do, I have it configured, is going to do every minute, it's going to shift 10% of the traffic, so 10, 20, 30, 40, and 50, and then at 50, it's going to deploy to everybody else. So we're going to see that in the logs in a second. I also have it comes with a Grafana dashboard here. Okay, let me, I have to forward the port. There it is. Where I can see the incoming, the new version, the existing version, the new version, the canary. I can see the CPU request, the CPU usage, the requests that are incoming, and I'm going to generate some traffic, so it gets some noise here. This is basically hitting the application, printing the return code, and what version. And you can see that some of them are returning 133, and some of them are returning 134. So it's already splitting the traffic. And in the logs, I see here advanced JX production, weight 10. So that means 10% of the traffic is going to the canary, which, so I have 134 deployed. The canary, I'm doing it the reverse, so it's 133. So if I refresh, I'm getting 134, 133, depending on this balancing of that Istio is doing. And I should get some traffic now here. Yeah. So the primary is the previous version. Canary is the version I'm deploying. So I can see the success rate, a type of all sorts of metrics you can add. All these metrics, you don't have to touch your application to do anything. Really, this is automatically done with Istio. So Istio is basically proxying all the requests to this application automatically. It's sending the metrics to Prometheus. So you get status codes, you get response time. And those are the two metrics I'm checking here. But you could, Istio adds more metrics, and you could create your own metrics. But for this, you don't need to touch your application at all. So what's going to happen also, okay, this is advancing, is 20, is 30%. Before this rolls out completely, if I do it quickly enough, I will show you how we can automatically detect that the new version is having issues and roll it, and how this is going to roll it back without you having to do anything. So let me open, and I'll explain this in a second. Yes. What I'm going to do, my application, I have a couple of special URLs that are going to return 500 errors and delays. So I'm going to force errors into my application to see how Jenkins X is going to handle those, Flagger is going to handle those, and roll back my application automatically. So I need to hit this URL. I'm going to run this. I need to run this from inside the cluster. And what I'm doing here is creating a dev pod. Jenkins X has this idea of dev pods, which are basically containers, Kubernetes pods that have a stack pre-installed. So you can choose, I chose a Golang pod, dev pod. So it's creating a pod and giving me a shell into it. So I can run whatever development environment commands that I want. I'll show you in a second. I just need to make it fail before it finishes deploying, or I have to start it again, which is too late. OK. It's too late. So it went up to 50%. This is good. I'll show you the whole thing. One is succeeding. The one is failing. So it went to 50%. And basically, now all the traffic is going to the version I have promoted. And let's see the curl. You see all the requests are getting version 133. So which was the one I was deploying. And if I go here to my Istio gateway, yeah, I'm getting version 133. And in version 133, well, this is, because I couldn't make the change, this is not the one I wanted to show. But you see that the release is 133, and it's a different commit. While in staging, I have 134. Staging hasn't changed. So I'm going to do the promotion again. I'm going to say, OK, I want to promote. OK. JX, get applications, JX, promote. That's version. So I'm going to promote 134 instead of 133, environment, production. OK. So this is going to do the same thing again, but changing the version. All right. So it has created a pull request. Same thing, GitOps repository. And this is going to be automatically tested and deployed. There it is. And in a second, this will be up. So I was here. My dev pod was created, so I can start injecting errors. So this is not just for errors. So let me show you again. Sync and this. So I'm creating the dev pod again. So you see I have different stacks. I have Go, I have Maven, I have Node.js. And this is reusing the one I created. The other feature it has the synchronization. So this should have worked, OK. So this is automatically copying my local contents to the remote pod. So if I go, I'm running out of consoles here. Is this one? Yes. And I touch a file. In my local machine, I can go to the remote machine, and my test file is here. So this allows you to edit your files, work on your development machine, change files, do whatever you want, use your IDE, and this gets automatically synced to Kubernetes. And in the remote machine, what I can do make, I can do a Docker build, I can do a Helm chart build if I want, with the benefit that this is all running remotely. So this is running on Google. It's using Google internet connection, which is going to be a lot faster than uploading Docker images from my development machine to a Kubernetes cluster and then doing it. So this helps you using the cloud to do the things that are heavier for your development environment. And OK, so let's try this again. And OK, so Flagger has now detected there's a new revision. So it's starting again the canary process. And in a second, it's going to shift 10% of the traffic. And we can see it here. You can see that after the Canary deployment before, the Canary version is not getting any traffic. That's a scale down, and all the traffic is shifted to the Canary is moved into production, and all the traffic is shifted to the new version, and the Canary is stopped. So it's all on demand based on when the Canary process happens. Okay, so I'm getting 10% of the traffic now to my Canary, and this is starting to pick up. This should be starting in a second. There it is, getting some traffic on the new version. What I'm gonna do is force the failure. And you see there's some of them are getting 134, most of them are getting 133. And I'm gonna force, I'm here, yes. I'm gonna force errors. So I'm gonna force my application to return 500 errors. And let's see what happens. So this is going to start showing that the success rate is dropping. And Flagger is going to detect that and do the rollback automatically. Okay, so the success rate is falling. And I think I have it configured. I'm going to show you the configuration, because this is going to take a little bit. Okay, here. So this is a YAML file that I include in my Helm charts. I'm saying Canary is enabled. These are the hosts that I use for Istio. And this is the Canary analysis, which is the important piece. So step weight is the 10% I'm increasing up to 50%. That's the steps I want. I'm saying do it every 60 seconds. And threshold is how many times can the metrics fail before I do the rollback. So if the metrics fail 3 times, do the rollback. And the metrics that I'm using is 2 metrics that are sent by Istio. I don't have to do anything in my application. So I'm saying, you know, every 60 seconds, check the request success rate and make sure it's over 99%. And make sure that the seconds, the duration of the request, is under 500 milliseconds. So check these 2 metrics, and if they fail, do the rollback. That's what I have configured. And this one. And you can see here, can you see it in the back? Yeah. What's happening here is halt the advancement, because the success rate is 93%, which is less than the 99% that I had set in my configuration. And the second time is, now it's 49%, which still fails. And the third time is now 44%. So this should automatically roll it back in a second, because it has noticed that the new version, the Canary version, is failing. And I can go back to Grafana. The success rate is going really, really down. I can also get these logs, again, the Flagger logs. You can get them in Stackdriver. Okay. So there it is, the halt the production deployment. So you can get all this information here. And in a second or more, okay, the sooner I say it, the sooner it happens. And yeah, so production, failed checks, threshold reached 3. And Canary fail, scaling down my Canary deployment in production. If I go to my curl, I see that now everything is returning 133. So it's all rolled back. And my Canary should stop getting traffic now, because it has been rolled back. So it's going back to the previous version. So I think, well, if you want to take a look at the application, that's the GitHub repo. And you can see how the Helm charts are configured. One thing I didn't mention, I'm just going to show it now. Other things that you can do with Jenkins X. You can do JX, create, quick start. It's a very easy way to start creating Kubernetes applications. So I'm going to create a demo next. And I can choose from one of the existing templates. So I can create an Android application, a Golang, a Node HTTP, a Spring Boot. So let's create a Spring Boot application. Yes, yes. So this has created the scaffolding for me. Let's go to my GitHub repo. So you see it has a Docker file, it has a Jenkins file, it has my Helm charts created for my specific type of application. And I have the deployment for Kubernetes, the service, everything is already configured. So this is a very nice way to start with your creating applications on Jenkins X.